Hello, it's Henrik Beshman here. I'm a software developer based in Toronto, and this screencast is basically a quick review of Eric Evans' book, Domain Driven Design. Hopefully, this will whet your appetite and get you to read the book itself, which is a fascinating read. And my copy has got lots of dog ears because I keep going back to it. Well, electronic dog ears. I've got the e version, of course. So I'm going to quickly go over design pattern background because that's at the core of his method. Talk about some of the essentials of domain-driven design fairly quickly. Cover some of the domain-driven design building blocks. Look into a few specific design patterns, and then round out the screencast with some general ideas that he has for dealing with complex applications. So a design pattern is a general solution to a commonly occurring problem, which can be reused and is helpful in many situations. It's also a good way to communicate among developers and to document your work in a way that will make it easier to go back to. Studying, adapting, and formulating design patterns can significantly advance software development skills because obviously it helps you to think abstractly and about the problem domains that you're working on, and develop skills in focusing in on designs that are going to be the most efficient and stable as you implement your designs and accumulate these things. So here's a longer definition. I'm not going to read it all, but you can see the bold writing at the bottom. You can become quite formal about this. Pattern name, classification, intent, motivation, applicability, structure, consequences, implementation, sample code, known users, and related patterns. I think that's what that's the structure that Gang of Five uses. You can use much simpler structures, depending what suits you. Look at the Martin Fowler article that's referenced there for some ideas. He does a bit of a survey, as is his wont. So some common examples. Most developers have heard of these. Factory method, prototype. Of course, JavaScript is based on the prototype design pattern. Singletons, just one instance of an object as a reference in memory. Handy to have information available at runtime. The strategy to find design patterns, sometimes known as a policy design pattern, where you submit a context as parameters and are returned an instance of a class that's going to help in a particular situation. So you can classify design patterns, and others have done this. For example, creational, structural, behavioral, concurrency. You can look them up under those categories. Their categories aren't limited to that. They could really be anything. Organizational design patterns, for example, comes to mind, but it's another good way to think about them. Design patterns actually started being described in terms of the software world that we work in by an architect around 1977, and Kent Beck and Grady Booch and others picked up on that and realized that similar concepts would be useful in the software world. So it was formally presented in 1987 at an object-oriented programming symposium. And And then in 1995, the classic design patterns elements of reusable object-oriented software by the four authors that have come to be known as the Gang of Four was published. And they've really been part of the mainstream, I think, from a few years after that. There's a group called the Hillside Group. Founding members were Kent Beck and Grady Booch, who invited a number of thinkers in the software industry to meet in Colorado. They ended up on a hillside, and so they formed this thing called the Hillside Group. You can Google that. There is a website which is something of a repository. Martin Fowler has written a book which is now probably something of a classic, design patterns applicable in enterprise applications. And of course there's the book Domain Driven Design, which was released in 2003, 2004, somewhere in there. Now, getting back to Domain Driven Design as conceived by Eric Evans, he does talk a lot about model driven development, which is behind the design. So modeling is a system of abstractions of the problem space, kind of a structuring and organization of the problem space, including the useful concepts, the characteristics or properties of those concepts, and some of the behaviors and interaction of those concepts, organized into a system that can help to think about the problem space in a way that helps to lead to the focus that's going to provide a successful software implementation in the long run. So it provides context and therefore meaning. It's able to relate to the users. It's able to relate to the developers, the user interface designers, and everyone involved. They are aids in clarifying, distilling, simplifying the ideas that are required for an implementation. And once they are distilled, a model can help to leverage the process by forming a foundation that can be efficiently implemented and also over time expanded and extended efficiently and effectively without running into a lot of confusion or problems. So models are used to expedite design. Design is used to expedite implementation. And then in terms of the agile methodology, which is common nowadays, of course the implementation is used to identify discoveries that can then be looped back into the design process. The essentials of domain-driven design include focusing on the core, that is, in the modeling exercise, identifying a very few ideas and structures that are going to give the most leverage and give the most meaning and give the most utility to the users of the software in terms of having impact. As Evans conceives the process, it necessarily relies on creative collaboration among both what he calls domain experts and software experts. So read people that are sometimes called owners or champions, product owners, or could be marketing people, people that are experts in the domain that's being addressed by the software on the one hand. On the other hand, the software development experts, notably the developers, From his point of view, they all need to be involved collaboratively. It is necessarily a process of exploration and experimentation. He shies away from the waterfall method, which is more traditional and relies more on what's known now as the agile method, that involves a lot of feedback and cycling and openness to experimentation without sacrificing results, without shying away, obviously, from moving ahead and moving towards deliveries really on an ongoing basis. One of the key things that Evans talks about is the value of identifying and kind of continually working on what he calls a ubiquitous language, terminology, nomenclature. One of the mechanisms that can be used to help in that regard is to have a glossary that's shared among everyone and that's understood among everyone, another living document as part of the process. He also has noticed that in complex applications, it is very helpful to develop context boundaries in order to limit sections of the problem in a large problem space to manageable sizes. And very importantly, from my point of view as a developer, he's found that it is extremely helpful to closely bind the design and the implementation. By that he means that one should be able to readily compare a design that is understood and used by people that are working on clarifying the application design in an abstract sense, people that are working on it from a domain expert standpoint, and the developers who are creating structures such as module structures, even directory structures, naming conventions that are used in source code files, and so forth. Those two sides of things should compare fairly easily, to the point, rather surprisingly from my standpoint, where non-developers should be able to, with a little bit of help and guidance, read through source code and actually gain insight into the details of the implementation, to the extent of being reassured that the implementation properly reflects the concepts of the design, and even to the extent of being able to then add to the discussion about refinements and an evolution of ideas. So he keeps coming back to these. It's a fairly short list, but quite a rich list, I think. So the first job in domain-driven architecture is to isolate the domain, and the classic way of doing that, something that should be done in any case for all but the most trivial application, is to apply this very basic design pattern called a layered architecture pattern, where there is separation of concerns into user interface application, which is marshaling the data and input from the user, sending information back, and then sending service requests down to the domain layer, and having the domain layer send service requests down to the infrastructure layer, including things like frameworks and also repositories, databases, and such. The key characteristic of a layered architecture pattern is that service requests are made to lower levels, and services potentially at the same level, but never to layers going up. That has to be done in different ways, possibly through services or through messaging mechanisms if that's required. But in any case, the key point here is to isolate the concerns or separate the concerns of the application, so that the domain layer, which is which is essentially the business rules, can be separated, and then further refined and evolved over time. So the ubiquitous language, as he calls it, is critical for this. You can see that there are the domain expert. There's the domain expert sphere on the left, and sorry, the developer sphere on the left, and the domain expert sphere on the right. There should be a large area that's shared between them, so that communication is meaningful and exact, and so that collaboration can move the process ahead well. He does point out several times that he's found that language seems to have a particular potency in moving concepts forward, and generally moving designs forward to successful conclusions. So this is probably the most meaningful point that he makes. The language of model-driven design, he's really got it boiled down to a few things. Again, stepping back a little bit to the model-driven design, I've circled a couple of key things there. I've underlined the layered architecture that I've already talked about, added services, entities, and value objects. I'll talk about those a bit, but essentially entities are objects that have persistence and therefore require an immutable identifier, whereas value objects are immutable and are transient and are passed around for functional purposes during the running of an application, but don't require permanence in that sense. Unless possibly they become part of aggregates, which you can see there to the right. And again, I'll talk about that in a bit. But it's actually a fairly compact and tidy view of the key ideas that everyone can focus on in terms of conceiving of an application. You'll notice that he's identified smart UIs such as the Angular JavaScript framework, which is quite common right now, as anti-patterns because the capability, the sort of broad capability of those smart UI frameworks makes it, in his view, too tempting to sort of pack too much of the application, including domain level things and even infrastructure items, direct communication to databases and such, into the front end, which from his point of view is a mistake. I agree with that. I don't think it's actually a bad thing to use Angular. I'm a big fan myself, or tools like that. I do think it's important to rely on an API and a back end and be sure that business logic is essentially processed behind that API rather than in the UI itself. So again, the key building blocks are the layered architecture, services, entities, value objects, aggregates, factories. Give a factory a context, get returned an appropriate object instance that's going to be able to operate on the data that's within the context. Repositories, of course, there are a variety of those to select from nowadays, and even combine graph databases, SQL databases, document databases such as Mongo, so all of that is good. Subsequent to the book, there seems to be quite a bit of chatter of adding essentially a log of all changes to a database, so that that log can be analyzed and mined for information, and also obviously to do rollbacks and analysis of that sort as time goes on. An important anti-pattern is to avoid objects that have no behavior, domain objects that have little or no behavior associated with them. So there's the layered architecture again. Services are essentially operations that can be viewed as global, such as creating a database connection, making a connection to an email delivery service, and so forth, communicating. Obviously, if an operation is specific to a class, then it belongs instead to that class. As I mentioned, entities are data structures with identities and persistence. Value objects are data structures that are invariant and have no identity. Aggregates is a fascinating design challenge, somewhat thought-provoking in the sense that Evans presents the challenge of hiding probably the majority of entities inside what are called these aggregates. An aggregate is defined as a complex data structure that has one entity, a well understood entity is at the root, and that any internal associated entities can only be accessed through that root, never directly, certainly not any more than in a very transient method. So there's this there's this example here from the book in which he talks about a car as being an aggregate, and to understand information about that car in terms of the wheels, the rotation of the wheels, one has to query through the root entity of that aggregate. The benefit of all this is it can not only sharpen an understanding of what the key responsibilities in a system are, which is critical to developing a robust system that can be leveraged going forward, but it also simplifies the application essentially by hiding a bunch of things, and therefore simplifies communication. So it's quite an interesting, powerful idea. Factories, return objects, repositories, I've talked about. They are charged with integrity, contention handling, latency issues in a distributed database. And again, with the variety of databases, many of them concurrent, there are issues of needing to synchronize databases, recover from integrity challenges, marshal objects that are required by the application layer from a variety of repositories, and then distribute data back to that variety of repositories. I guess in particular I'm thinking that modern applications in many cases really nowadays require at the very least document database. I think graph databases are becoming much more widely used because they have a great deal of utility in terms of being able to manage relationships among data sets, and of course classic SQL databases where there's the need to have that kind of relationship, that kind of ready querying capability, ability to do inversions and such. So very interesting topic there. And then the domain events I've mentioned already as being something that seems to be gaining favor. Okay, so very quickly, that was an overview of the concepts that Evans covers in his book. He does a much better job, obviously, than I do. I very much recommend going back and looking at those things. I just wanted to close out by touching on a few things that he raises that are, in his view, available to help with more complex application design. So think strategically in terms of broad structures, organize your work so that design can be gradually clarified really on an ongoing basis forever. It never ends. Documentation should be living. When a documentation set is no longer relevant, then let it drop away, or pick out a few things that are still relevant and reorganize that into a new document going forward. Don't get too stuck on it. Look at model integrity patterns. Take a strategic view of the key concepts that are being distilled, and then setting the stage as a way of getting organized. So there's strategic design. Context map means that when you do have context boundaries, create a translation map, essentially, so that it's very clear how terminology in one context area relates very specifically to terminology in another context area. For large scale structures, think in terms of metaphors, responsibilities, knowledge level. Complex applications often use a technique of allowing advanced users to essentially modify the structure behind the interface in order to adapt to changing circumstances. Kind of a building approach. And so what he's saying is identify those, take advantage of them, but be careful to rely on the knowledge level of the users that are going to have access to those kinds of things. Use pluggable components where they're available, and as always, keep working on the evolving order and structure of a system without letting it get out of control, in the sense of becoming fuzzy, poorly understood, mismatched, all of which can lead to a situation called the ball of mud, where applications, although they may be functional, become so difficult to modify that there's really, at some point, very little that you can do with them. Supple design, intention revealing interfaces. This is, really getting closer to the implementation side of things. Use assertions, use side effect free functions, closure of applications, standalone cloud, all those good things. Just be careful, take a bit of time, make sure that there are boundaries around all the implementation components that are being created. Model integrity patterns, use a shared kernel. Make sure that people downstream are being given an opportunity to provide feedback upstream, so that, for example, testing people are able to have an influence on the design of the testing system, even so that the user interface people are able to have an impact on the back end without imposing designs on people downstream that they're going to find to be dysfunctional. An anti-corruption layer is an interesting concept where there are disparate databases. The idea is to have to be systematic about creating layers that take data in, review the data, and make sure that it conforms to the local database definitions. And for ongoing distillation, keep the domain vision in mind. Maintain a focus on the core or a few select cores. Try to be abstract about it. Just really keep working on clarifications. Look for generic opportunities. Look to have a clear and consistent declarative style throughout the process. And for setting the stage, don't spread the modeling too thin. Just means focus on the challenges, on the areas that need feasibility work, perhaps. Focus on the core domain more than other areas. The sort of more peripheral areas, reporting comes to mind, tend to take care of themselves or can be pulled out and replaced fairly easily, whereas embedded items, in particular the core domain, because it has ripple effects everywhere, need much more care. Use clean bounded context everywhere, and always rely on an iterative process. Always rely on collaboration between the domain experts and the developers. And at all costs, keep things from degenerating into a big pile that is stuck together with twine and duct tape, because then you'll be lost. So, the key points in domain-driven design are a layered architecture, services, entities, value objects. Entities and value objects collected into aggregates, which have clear boundaries. Factories for essentially making decisions that are appropriate to particular contexts and operations. And of course, repositories. So read the book. If you have any questions, feel free to contact me at the address that you see there, and have a good day.